neatly, slowly. So we all know that circular path, we already studied in the chapter 1. So we know that circular path, who is always remains constant, always, all of you?
Magnitude.
Magnitude of velocity. Magnitude of velocity is only called as what? Everyone?
Speed.
Yes. Magnitude of velocity, we used to call as what? Is called speed. So speed of the body remains constant, but direction of the body is what? Speed is remains constant, but as we know, direction is not constant. Direction is keep on changing. Direction is at every point in the circular motion, direction changes. So direction changes means somebody is also changing. Who is that? Direction
Velocity.
Velocity. Velocity changes in a circular motion at every point. Am I right or wrong, everybody? All of you? Now, if you notice it, all of you observe, nobody can change the direction. Because suppose your car wants to change the direction, you have to apply what, everybody? You have to apply what? Some force. Yes or no? If you want to change the direction of your body, you have to apply the force. If you want to change the direction of somebody, you have to apply the force. Now, in circular motion, who is changing this? How that velocity, the direction of the body is changing? Is it simply automatically changing or some force is exerting? Anybody?
Force is exerted, sir.
Force is exerting. You understanding? So, a body in motion cannot change its direction on its own. No body can change its direction on its own. If it wants to change its direction, what it has to do? A body moving along a circular path, it will be definitely influenced by an external force. That external force is only we used to call as, what force we used to call? Centripetal force, which can make a body move along a circular path, which is acting always perpendicular to the direction of velocity, which is always acting perpendicularly to the direction of velocity and always act towards to a fixed point. That fixed point only we used to call as, what we used to call? Center of clear, everyone? So there is an external force which makes the body always need to change the direction at every point in a circular track. That force only, what force we used to call, everybody? Centripetal force. Centripetal force always perpendicularly to the velocity and as well as acting always towards to the what, everybody? Acting always towards to the, please respond. Center. Okay, so that is what? So optical center of the circle, let me take O, not C. And it is always perpendicularly to the what? Center. Perpendicularly to the velocity. Understanding? So at every point, every point the direction is changes. So at this point, the direction of the body is like this. And here the centripetal force is acting towards the center. At this point, the direction of the body is like this. It is the centripetal force is acting towards the center. So always both are what? FC, centripetal force. FC, centripetal force, FC. So at every point, velocity is not constant. V1 velocity, V2 velocity, V3 velocity. Why I am taking V1, V2, V3? Why, guys? Because at every point, what is that? Something is changing. What is changing?
Direction.
Direction is changing. But something is constant. Who is constant?
Magnitude of velocity.
But direction is changing. So that is why I am taking V1 velocity, put up arrow, V2 and V3. Arrow indicating what? Velocity. So always there is the external force which makes the body direction keep on changing and always which is acting towards to the fixed point. That fixed point only called as, what is the point? Fixed point? O, center. Understand? Center. And it is always acting perpendicularly to the direction of velocity. That is why, what is the angle between them? Perpendicularly means?
90 degrees.
What is the angle between them? The direction of force and as well as the velocity is always, what is the angle, everybody?
90
degrees. So this force only we used to call which changes the direction of a body continuously in circular track, always acting towards to the fixed point and perpendicular. Always it is what? Perpendicularly to the direction of velocity. Always perpendicularly to the direction of velocity and always acting towards to the fixed point is called as what force, everybody? Which to called as
Centripetal force.
Centripetal force.
and this write the first definition, then we'll proceed. Okay, do you all understand what is centripetal force, Shivani,
Yes, sir.
Nivedan?
Yes, sir.
Yes, sir.
That is what. So for example, body is here. The body's direction is like this and centripetal force is like this. Not only this, sir, you are taking exactly at the point. For example, here I will take. This is the direction. How to draw how to find a direction I taught you already in first chapter. Can you tell me how to draw a direction? By drawing the
Sir, tangent, sir.
very
When there
good,
is
Nivedan.
non-uniform
Lingesh, are you
motion.
there in a meeting? By drawing a
Sir,
what?
when there is non-uniform motion, tangent helps us to
You
find,
need
sir.
to draw a tangent. By drawing a tangent, you can find the direction. And at that point, if I draw towards to the center, that is only for centripetal force. Now here also, what is the angle, everybody? What is the angle? 90
degree.
Understand, Mr. Lingesh? Are you there in meeting? Gokul Raj? Very good. For example, at this point, the direction is like this. This is the direction of velocity. Now, here also, the force is acting towards the center. Here also, what is the angle, everybody? 90 degrees.
90.
At every point, somebody is pulling towards the center so that the body is keep on moving in a particular direction. Every point, the direction is keep on changing. So who makes the direction changes in a circular track? What force it is? Centripetal.
Centripetal
That is what you should understand. So please write it. A force which can make a body, do you all understand or not, Amma? Everyone? Yes? Please respond.
Yes, sir.
Yeah, right. A force which can make a body. So Lingesh, are you there in a meeting? Make a body move along a circular path. Circular path is the force acting perpendicularly to the mute amma, somebody is having nice, you see that acting perpendicular to the whom, guys? Tell me fastly. Pranav, Lingesh,
To the center.
perpendicularly to the direction of velocity. Understand, Mari? Towards to the center. Perpendicularly to the direction of velocity and always directed towards the what?
Center.
Yeah,
Center.
always directed towards to the center. That center only, towards to the center only, we used to call it as a fixed point. Okay, so what is the angle between them? Perpendicular. Clear?
90.
So that is what? Direction of velocity is perpendicular. This is a symbol for perpendicular. Inverted T. It is indicating what, everybody? Perpendicular. So what is the angle between them always? 90 degrees. Clear? everybody? Yes, please.
Yes, sir.
So now, sir, what is this value? The centripetal force. For example, if I want to calculate the centripetal force acting in a body, so the formula is mv square by r. Of course, we will derive the formula also. You no need to worry. So what is the formula? Centripetal force formula? mv square by r. Clear? So m means mass of the body. M means what, everybody?
Mass of the body.
Mass of the body.
Awesome.
V means what? V means velocity or magnitude of velocity? V means
Magnitude of velocity.
yes.
Magnitude of velocity. Sir,
Magnitude
that's
of,
not Q, sir. It's V.
yeah, V Mari, V. V means magnitude of velocity. Because direction doesn't matter. Because we are considering here speed is remains constant or varies, everybody. Magnitude of velocity remains constant or not? All of you. Yes.
Yes, sir.
That is what.
Constant.
So magnitude of velocity, which is called as what? Magnitude of velocity known as Shivani.
Speed.
Speed.
Next, R. R indicate what? Anybody can tell? R indicate
Radius.
radius
Radius.
of the what?
Radius.
Radius illa, Gokul. Radius of what? Radius of
Circular path.
circular path. Very good. That is what you should remember. So, the centripetal force depend on three things. Anybody can tell what is the three things? Alpine,
Magnitude, direction,
magnitude not. Direction don't speak, Mari. Direction doesn't matter for us. I'm asking centripetal force depends on three factors. So what is that? Mass of the body.
Mass of
Next,
Mass of the body.
magnitude of velocity.
magnitude of
Radius of
velocity
circular path.
and as well as radius of the
Radius
circular
of
path.
circular path.
Understand, Mari? So, for example, the body, particularly a body which is revolving in a circular track, having a mass m. You understanding? So, this mass of the body will decide the centripetal force. The velocity, sorry, the magnitude with what speed it is traveling will decide the centripetal force. And what is the radius? Radius of the circular track, that will decide the radius means this only radius. Am I right or wrong, all of you? R.
Yes, sir.
So always keep it in mind. Now, new statement I'll put. Centripetal force always act along the radius or towards to the center. Do you understand what I'm saying? The centripetal force acts always along the radius or towards to the center. Both are same or not, everybody? Clear?
Yes, sir.
Yes, please. That is what. So please remember that. R means radius. So please note it that. Centripetal force always act what? 11th class again it will come. Along the radius
Along the radius
or-
and perpendicular to the center.
or towards to. Towards to the what?
Center.
Center.
Towards to the center. That is what. So what is the formula for calculating centripetal force, everybody? Yes, please.
Fc is equals to mv squared by
F
r.
is equal to
By
mass.
M means mass of the body, V means magnitude of velocity, R means radius of the circular track. Okay. So we can say, if anybody will ask you, centripetal force depends on the what? Three factors: mass of the body, magnitude of the velocity,
magnitude of
as well as
And radius of
radius of the
radius of
circular
the
path.
circular track. Clear, everyone? That is what. Okay. So now everything it is C, relation. Centripetal force is directly proportional to mass of the body. Centripetal force is directly proportional to square of magnitude. Do you understand what is the meaning of this one? Square of magnitude
Yes, sir.
of velocity. Magnitude of velocity. What is the magnitude of velocity we used to call?
Speed.
Called as speed.
Speed.
Clear? Now, but what is the relationship between centripetal force and radius? Anybody? Inversely proportional to each other. So, if radius of the circular track increases, if R, radius is increasing, tell me, centripetal force decreases or increases? Both are inversely proportional.
Pieces.
Decreases. Ellame puriyamama? All of you? Understand? So, radius of the circular track is increasing. The centripetal force, what will happen? Everybody? Sangamitrai? Decreases. Number. But what about the mass? Mass increases, centripetal force also increases. Magnitude, speed increases, centripetal force also increases. Clear, everyone? Understand or not? Yes.
Sir.
That
Yes,
is
sir.
you have
Yes,
to
sir.
remember. Yes, Nivedan, any doubt?
No, sir.
Okay. So this is what. So the next class we will study how many times it is increases. If mass become double, then what about the force? If velocity become double, that is what, sorry, magnitude of velocity become double, then what about the force? If radius become double, then what about the force? These all the things we'll discuss in tomorrow. Remind me if I forgot also. And then next we are going to study next important force, centripetal force it is. The next force we will study centrifugal force. What force, everyone?
Centrifugal.
Centrifugal force. Both are not same. Okay. Centripetal and centrifugal force. Tomorrow we'll study what is centrifugal force and what is rigid body and all, and we'll continue further. Okay. So this is what about it. Anybody having any doubt, you can ask me, or else we'll stop it. Okay, guys. I will understand
So
today's.
what's the last one, sir?
Yes, Amma.
Can you read the last one?
Which one?
Centripetal force.
Centrifugal force.
No, sir. FC is proportional to.
FC is proportional to inversely proportional to radius. This is called as inversely proportional 1 by R. Because formula it is C. Have you seen 1 by R? It is a division. Understand, Shivani?
Yes, sir.
Inversely proportional to radius. If you want to write the statement, force, centripetal force is directly proportional to mass, directly proportional to square of velocity. That is a square of magnitude of velocity, and inversely proportional to radius. Okay.
Yes, sir.
Yeah, that is what. Understand, Amma, everyone? Alfin, Asani, that is. Okay. So please clear your doubt and we'll continue from here. Tomorrow's class. Thank you, all of you.
Thank you, sir.
Yeah.